Good day, I am leader of this project. We'll be presenting the video about photocatalytic degradation of textile wastewater. This project is some of my PhD research. Member of this project is DS Dr. Ong Hui Rui from the RB Highcom University and also Prof. Maksudur Rahmat Han from University Malaysia Pahang. For background study, water pollution issue problem will be tackled. More than 700,000 tons of dye used globally each year. This problem can cause poisonous and carcinogenic dye wastewater. To solve this problem, synthesis of new catalysts will be done to decompose organic waste in textile wastewater. When we compare the radiation, visible radiation contributes around 40% of total energy from the radiation. Therefore, the critical to make visible light responsive photocatalysts, we can increase absorption in the visible range. The presence of the catalyst photooxidation accelerates the photoreaction. Therefore, the heterojunction of ferrite with other will purposely to improve their photocatalytic and properties efficiency. This technique is application to the photocatalysis technology in industrial textile wastewater. Second part is problem statement. The problem in this topic is divided into two. The first one is about textile wastewater. Industrial wastewater contain color that extremely damage to the environment and has carcinogenic and mutagenic effect to the aquatic and also human. Second part is the activated sludge treatment has poor result on dye degradation due to the high chroma, salinity and biotoxicity of dye effluent. The next part is about the catalyst itself. The catalyst, visible light active catalyst, is required for the photodegradation process because we want to tackle on the visible light irradiation. Why we need to tackle on visible light irradiation? Because the amount of radiation is higher, 40%. Then, aim of this project is on photocatalyst for photooxidative breakdown of organic molecule in the effluent or textile wastewater. After we know about the topic of this project and also the problem that need to tackle, we go for the methodology. For the methodology is divided into two, catalyst preparation and photocatalytic degradation. For catalyst preparation, the nickel nitrate precursor method is used to make nickel copper ferrite. In this project, we will create or synthesize the metal ferrite catalyst. So, nickel nitrate, copper nitrate, iron nitrate, nitric acid is used to prepare the catalyst. Next part is for the photodegradation. For the photodegradation, dye was injected into the photochemical reactor. Then catalyst will added into the system and we keep in the tank within 30 minutes. After the 30 minutes, we will take the sample for the dark environment. Later on, the light was turned on to start the photoreaction. The sample will be taken every 30 minutes in order to see the degradation of the dye. Now we will go for the laboratory work. This figure shows the synthetic dye. In this project, we use mentholin blue dye before we go for the real textile wastewater. This figure shows dye after we make a solution up to 20 ppm. This is weighing machine. This figure shows catalyst preparation. The sample is heating to dry the solution. After the heating process, the solution turn to dry sample, and sample will go for the furnace to burn the sample. This is my figure while waiting for experiment work. Then this figure show after burning process. We will wait until sample turning cool and we take out the sample. After the sample cool, we will crush the sample until tiny size. The black sample is for copper ferrite metal, and for the white sample is after we mix the copper with graphite sample. Okay, for the catalyst preparation is done. Second part is for dye degradation. Sample, this figure show dye degradation setup. In dye degradation activity, the sample will be taken out every 30 minutes. This show the sample after we take out every 30 minutes. We can see the degradation of color of the sample. The longer time of photo degradation activity happen, the color of the solution of dye degrade or turn to clear. After that, the analysis activity will be carried out. The UAV experiment is done to see the absorbance and wavelength of the solution. After the experiment of catalyst preparation and dye degradation is done, all the apparatus will be cleaned up. Okay, now we go for result. For result, we divide it into 3 tables. The first table is explain that we compare 3 varieties of catalyst weight. The highest of percent reduction is on 0.15 gram. The below table is we vary the catalyst composition. So we can see that only dye no catalyst, the percent of reduction 54, but when we add with copper molecule with composition 0.25, 0.75, the percent degradation of percent reduction up increase up to 79.4%. Then we mix with the graphite, the percent reduction increase more up to 94.78% reduction. We can show that the catalyst synthesized to dye reduction based on this result. The copper molecule mixed with graphite is the highest of percent reduction. Next, we go for UV liquid analysis. We can see this graph, these 2 graphs show that the reduction of dye concentration solution versus time. So, the increase of the time, the dye concentration reduced drastically. After we refer to the result and can answer for the problem, the level of impact is we able to prepare visible light response catalyst, which is one of the option to dye photodegradation process. Second part is we able to reduce the concentration of fountain discharge, which referring to the environmental element. For industrial partner, we do some collaboration with Rebound Industrial Berhad, and for Natural Basket Village is our potential industrial partner. Next one is commercialization potential. Our synthesized photocatalytic catalyst is can be do for another wastewater type. For example, format, palm oil, wastewater, or another organic content in wastewater. Last but not least, for the conclusion, when we go for the result, before this we can see that copper molecule mixed with graphite catalyst achieved to reduce 94% of concentration reduction after 150 minutes of reaction under visible light using our new photocatalytic reactor. The color of dye we can see on the result picture. After 150 minutes photocatalytic reaction, the solution of dye turn more clear compared to the initial part. Therefore, the low cost of heterojunction catalyst will be provided, an alternative to treat the polluted synthetic dye to support the national policy on environment. Thank you very much for watching and listening my video. Thank you very much.